Okay, welcome everybody. This is the tail end of Chapter 3. We're talking about cost-benefit analysis related to the cost of pollution and pollution abatement on the ability of business to produce and distribute products and its impact on natural resources. So we've got a few concept questions that we want to talk about. First, what is natural capital? Natural capital is defined as the Earth's resources and processes which sustain living organisms, including human beings. Natural capital includes minerals, forests, soils, groundwater, clean air, wildlife, and fisheries. Economies depend on the natural environment as sources for raw materials and sinks for waste products. Both sources and sinks contribute to natural capital. In addition, the environment provides natural capital for human production and consumption. Resource degradation and pollution represent the overuse of natural capital, which threatens its long-term future. So we're in danger of overusing the natural resources and of generating too much waste for the environment to actually deal with. Okay, next question. Why are national income accounts an incomplete estimate of total national performance? And the reason is national income accounts are a measure of the total income of a nation's goods and services for a given calendar year. They are incomplete estimates of the total national economic performance because they don't incorporate environmental factors such as natural resource depletion and the cost and benefits of pollution control. The marginal cost of pollution is the added cost of an additional unit of pollution. The marginal cost of pollution abatement is the added cost of reducing one given type of pollution. It's difficult to assign dollar values to these activities, and as a result, it becomes extremely difficult to determine the cost-benefit analysis for things like gross domestic product, or even the net productivity for a given business when you bring in these external costs, these marginal costs. The optimum amount of pollution from a strict accounting standpoint is the amount of pollution that's economically most desirable. And in order to arrive at the optimum amount of pollution, you have to strike a balance between the marginal cost of making that pollution and the marginal cost of the pollution abatement. Again, this all affects the cost of your product, and if it becomes prohibitively expensive to engage in the activities, then the cost passed on to the consumer is going to reduce the amount of product that you can actually sell. So an accurate accounting of these activities is vital, but it's also very difficult to determine. How do command and control regulation and incentive-based regulation differ in pollution control? Well, command and control regulation is an example of what we call unfunded mandates, where the federal government will write a regulation and enforce it without providing the capital to carry out the regulation, to adhere to the policy. Incentive-based regulation is different. In incentive-based regulation, what you do is essentially sell the right to deplete a natural resource or to use the environment as a sink for the disposal of waste. And what happens very often in incentive-based regulations, not every time, but frequently, is that innovative and less expensive ways to clean industrial effluents and to more efficiently utilize natural resources without depleting them at such a rapid rate are devised as a result of the driving force here, which is the incentive to produce your product less expensively while being within regulation so that you're not going to have your business shut down. So let's take a look at some case studies. International policy experts think that the cap-and-trade system, which is an incentive-based system, is the most promising approach to manage the climate change problem. This is CO2 emission. We're talking about these buildup of these greenhouse gases. This encourages people and countries to find innovative and inexpensive ways to reduce emissions because they want to maintain their standard of living while at the same time not degrading their environment. And in lieu of an unfunded mandate, when you have some sort of an incentive to come up with a newer and less expensive way to actually comply with the regulations, the likelihood is that you're more likely going to find a technology or an approach that will be able to accomplish both. Whereas command and control regulations very often simply shut down or strangle production of your particular product. If we look at acid rain, the EPA in the 70s and 80s used command and control regulations mandating that coal-burning power plants reduce sulfur emissions, and these plants installed expensive equipment to do so. But by the 80s, plants knew of cheaper ways but didn't have the incentive to adopt them. There was nothing in it for them to actually employ these sulfate scrubbers and these devices that can remove particulates. And as a result, the goal wasn't accomplished. We didn't reduce the amount of waste produced as a result of this command and control approach. The Clean Air Act Amendment of 1990 stated that the EPA can limit the amount of sulfur emissions. Each year, the amount that's allowable is dropped. These permits can be bought and sold on the market. As a result, the industry adopted a variety of technologies to reduce emissions at a lower than expected cost and ahead of the EPA's reduction schedules. However, cap and trade doesn't always work. It hasn't been successful with water pollution because it's a much more complex situation involving more than one country, more than one continent. And often the effects of polluting things like the world's oceans aren't immediately apparent to the population of the country that's actually carrying out the activity. And so people are reluctant to adopt these regulations or to enforce cap and trade. And here you can look at a couple of examples of the effect of these type of regulations on sulfur emissions. On the left you see a West Virginia coal burning power plant. Plants such as these were a source of the components leading to acid rain. Until the 90s, the EPA mandated emission control technology, and since then the companies have had more flexibility in how to reduce these emissions. What you see on the right are some buildings in Ottawa, Canada that have been damaged by acid rain. This is an example of an externality caused in part by these emissions from coal-burning power plants in the U.S. However, it's also caused by other factors in the environment that aren't related to these activities, and as a result it gets difficult to assign a dollar value to this type of depreciation. So this is one of the challenges in cost-benefit analysis, taking this type of approach. It's all well and good to talk about the fact that there is a marginal cost of pollution and a marginal cost of pollution abatement, but until it becomes easier to actually pin a value, an exact dollar amount on these activities, it's going to be very difficult for classic accounting methods to accurately pin a cost on the activity and as a result provide an in-depth and accurate analysis of the problem so that we know what activities to engage in order to reduce pollution and maintain our natural environment. Okay, that's it for Chapter 3. I'm seeing everybody in class tomorrow afternoon when we're going to talk about the effects of pollution on human health. I'll have this uploaded to YouTube tonight, and I hope to see everybody tomorrow. Have a good evening.